What if I told you that scientists have built a machine that could accidentally create a black hole and destroy the entire planet? And what if I told you they already turned it on? In 2008, CERN, the European Organization for Nuclear Research, flipped the switch on the Large Hadron Collider, a 27-kilometer underground machine designed to smash particles together at 99.99991% the speed of light. And according to their own scientists, there was a non-zero chance it could create a black hole right here on Earth. Some people filed lawsuits trying to stop them. Others panicked, and a few made jokes about our collective doom. But CERN turned it on anyway. Now here's the thing. We're all still here. The planet hasn't been swallowed by a microscopic void. But CERN's website still says the Large Hadron Collider could create a black hole. So the question is, did we just get lucky? Or is there something about black holes we don't understand? Because here's what nobody tells you. The math says it could happen, and if it does, the consequences will be absolutely catastrophic. Welcome to the Curiosity Beast. I'm about to show you exactly how close we came to accidentally ending the world in the name of science, and why some physicists think we're still not out of danger. Let's go. Okay, so before we talk about whether CERN can destroy the planet, you need to understand what makes black holes so terrifying in the first place. Imagine this. A black hole appears in the center of your city. Not a massive one from space, just a tiny one, the size of a marble. At first, nothing happens, but then slowly, things start falling toward it. Dust, air molecules, then chunks of concrete, cars, buildings, people. And here's the nightmare part. Once something crosses the event horizon, the point of no return, it's gone, forever. Not even light can escape. The laws of physics as we know them break down completely. Within hours, that tiny black hole would have consumed your entire city. Within days, it would start eating the planet from the inside out. The crust would crack. The oceans would drain into the void. And eventually, Earth itself would collapse into a sphere of darkness no bigger than a ping pong ball. Terrifying, right? Now in nature, black holes form when massive stars, at least 20 times the size of our sun, collapse in on themselves during a supernova. The forces involved are unimaginable. Atoms are crushed together so violently that electromagnetic forces, the things that normally keep matter from occupying the same space, are completely overcome. Gravity wins, and the star collapses into a singularity, an infinitely dense point surrounded by an event horizon from which nothing can escape. But here's the thing most people don't know. You don't actually need a giant star to make a black hole. Theoretically, you can make a black hole from any amount of mass, even something as small as a proton. You just need enough force to compress it. And that's exactly what the Large Hadron Collider does. It takes particles and smashes them together with absolutely insane amounts of energy. So the question everyone was asking in 2008 was simple. Is that enough force to accidentally create a black hole? Before I answer that, drop a comment right now. Do you think CERN is playing with fire? Or is this all overblown panic? Because what I'm about to show you might change your mind. The Large Hadron Collider is the most powerful particle accelerator ever built. It's a 27-kilometer underground ring buried beneath the border of France and Switzerland. Inside, protons are accelerated to 99.99991% the speed of light and then smashed together. When they collide, the energy is so intense it recreates conditions that existed a fraction of a second after the Big Bang. And in those collisions, new particles are born, particles that didn't exist before. This is how scientists discovered the Higgs boson in 2012, a particle that gives all other particles mass. Without it, atoms wouldn't exist. You wouldn't exist. It was one of the greatest scientific discoveries in human history. But it came with a cost. Because to find the Higgs boson, CERN had to push the LHC to its limits. And that's when physicists started asking uncomfortable questions. What else could we create at these energy levels? Could we accidentally make something dangerous? The answer, according to some scientists, was yes. We could create a black hole. Now, when this news broke, the reaction was immediate. Headlines screamed about the end of the world. People panicked. Lawsuits were filed trying to shut CERN down. Facebook posts claimed CERN was opening a portal to hell. I'm not joking. That was a real conspiracy theory. Obviously fact-checked and debunked, but the fear was real. And honestly, the fear wasn't completely unjustified, because CERN themselves admitted it. Their own safety report said there was a theoretical possibility the LHC could create microscopic black holes. So why did they turn it on anyway? The answer lies in the math. And this is where things get really interesting. To understand whether the LHC can create a black hole, you need to know how much energy it takes to make one. Scientists measure the LHC's collisions in tera-electron volts, or TE. 1 TeV is roughly the kinetic energy of a flying mosquito. Doesn't sound like much, right? But remember, that energy is being packed into protons, particles so small you'd need 500,000 of them just to equal the width of a human hair. So you're taking the energy of a mosquito and concentrating it into something unimaginably tiny. That's a lot of bang for your buck. When the LHC first started, it was smashing particles together with 7 TeV of energy. Today, it's up to 13.6 TeV. And CERN is planning an even bigger machine, the Future Circular Collider, that will reach 100 TeV. But here's the thing. Even 100 TeV is nowhere near enough energy to create a black hole under normal physics. In 2010, scientists calculated exactly how much energy you'd need. The answer? About a third of the Planck energy. That's the point where our understanding of physics completely breaks down and quantum gravity takes over. And that number is a quintillion times higher than what the LHC can produce. So we're safe, right? CERN can't possibly make a black hole because they don't have nearly enough energy. Well, not so fast, because there's a catch, and it's a big one. What if our understanding of reality is wrong? See, we normally think of the universe as having 4 dimensions. 3 dimensions of space, forward and backward, left and right, up and down, and 1 dimension of time. But some physicists, particularly string theorists, believe there are more dimensions, tiny, hidden dimensions folded up so small we can't see them. If those extra dimensions exist, and that's a massive IF, it changes everything. Because in a universe with extra dimensions, the math on black hole creation completely changes. The energy requirement drops dramatically, low enough that the LHC could theoretically create microscopic black holes. So if string theory is right, CERN might have already created black holes. We just haven't detected them yet. And if they did create one, and it didn't immediately evaporate, we'd have evidence that string theory is correct, even as the black hole started consuming the planet. Talk about a Pyrrhic victory. Now, before you panic, let me tell you why we're probably still safe. And there are actually multiple reasons. Hit that subscribe button right now, because what I'm about to explain will completely change how you think about black holes. Reason number 1, Hawking radiation. In 1974, legendary physicist Stephen Hawking proposed something revolutionary. He said that black holes don't just suck things in, they also emit radiation. Very, very faint radiation, but radiation nonetheless. This happens because of quantum effects near the event horizon. And over time, this radiation causes black holes to lose mass and energy. For massive black holes, this process takes trillions of years. But for microscopic black holes, the kind CERN might create, it happens instantly. We're talking faster than a billionth of a second. The black hole would appear and then explode in a tiny burst of energy before it could consume a single atom. How much energy? Let's do the math. If you took all the energy from a 14 TeV collision and packed it into a black hole, then released it, it would have roughly the same energy as a grain of sand moving at 2 meters per second. If that exploded in your hand, you might barely feel it. Maybe. That's it. That's the apocalypse everyone was terrified of. Now, we've never directly observed Hawking radiation from a real black hole, but smaller scale experiments with sonic black holes suggest Hawking was right. So reason number 1, we're safe? Any black hole CERN creates would vanish before it could hurt anyone. But what if Hawking was wrong? Okay, let's imagine the worst case scenario. Hawking radiation doesn't exist. The black hole doesn't evaporate. It's stable. And it's sitting there in the middle of the Large Hadron Collider. Would it start devouring the planet? No. And here's why. Contrary to what movies show you, black holes are not cosmic vacuum cleaners. They don't just suck everything in. You actually have to get close to the event horizon for gravity to trap you. And remember, We're talking about a black hole with the mass of a proton or two, maybe a few atoms if it's lucky. That's an absolutely tiny gravitational pull. If you're not being sucked into your phone or your coffee cup right now, you're definitely not getting sucked into a black hole the mass of a few protons. But wait, there's more. If the black hole formed from charged particles like protons, it would still have that electric charge, and charges repel each other. In fact, a Harvard physicist named Avi Loeb published a paper in 2024 suggesting that a charged black hole could actually bond with an electron and behave like a weird little atom, a black hole atom. It wouldn't be stable, but it also wouldn't be dangerous. It would just sit there on the floor, pushed up by electromagnetic forces, exactly like your feet are right now. So reason number 2, we're safe? Even if the black hole doesn't evaporate, it's too small and too charged to do any damage. But wait, what if the black hole has no charge? All right, let's strip away the charge. No Hawking radiation, no electromagnetic repulsion, just a tiny neutral black hole. Now, would it eat the planet? Still no. And this is where it gets weird. Without charge, the black hole wouldn't be repelled by the atoms in the floor. So it would just fall, straight down, through the floor, through the Earth's crust, through the mantle, through the core, and out the other side. And along the way, it would barely touch anything. Here's why. Atoms are mostly empty space. If you scaled up an atom's nucleus to the size of a marble and put it in the center of a football stadium, the electrons would be orbiting somewhere in the bleachers. Everything in between? Nothing. Just empty space. And our neutral black hole, with no charge to interact with electrons, would just fall straight through all that emptiness like a ghost. Sure, it might occasionally bump into an atom's nucleus, but the odds are ridiculously low. To put this in perspective, 100 trillion neutrinos pass through your body every single second. And over your entire lifetime, the odds of even one of them hitting an atom in your body is about 1 in 4. 1. In your entire life. Our black hole would have similar odds. Even if it stuck around for billions of years, it would barely gain any mass. And here's the final nail in the coffin. CERN isn't doing anything nature doesn't already do. Every single day, high-energy particles from space, called cosmic rays, slam into Earth's atmosphere with the same energy levels as the LHC creates, sometimes even higher. If those collisions could create dangerous black holes, it would have already happened, billions of times over billions of years. And yet, here we are, still alive, still not inside a black hole. So there you have it. Could CERN create a black hole? Technically, maybe. If string theory is right, if extra dimensions exist, if Hawking radiation doesn't work the way we think. But even if all of that happened, and CERN created a black hole, it would either evaporate instantly, sit harmlessly on the floor, or fall through the planet without touching anything. The odds of it actually destroying Earth? Astronomically, impossibly, ridiculously low. So I think we can all sleep soundly knowing CERN is not going to end the world. Unless, of course, they really are opening a portal to hell. In which case, we should probably look into that. So what do you think? Is CERN playing it safe, or are we one experiment away from disaster? Let me know in the comments. And if you made it this far, thank you. Smash that like button, share this with anyone who's ever been scared of the Large Hadron Collider, and subscribe to the Curiosity Beast. Because the universe is full of mysteries, and we're just getting started. See you in the next one. Stay curious.